Hi and welcome to Cherry Pie Math. This video is going to introduce you to two-step equations. To do this, I would recommend knowing these things. I would recommend knowing what PEMDAS is, know what the inverse operations of the PEMDAS part is, so multiplication, division, addition, and subtraction. Know what a variable is, and know what mathematical equality means. We're not going to get into like English class or anything, but mathematical equality is just, you know, if you put it on a scale, it would be the same on both sides. Okay, so first I want you to look at these and I want you to match them to their inverse. So pause the video and make sure you know which inverse is which. Okay, so hopefully it kind of looks just like two x's here. And one cool thing about inverses is that if you have, like, these are just starter numbers, I guess. But if you add 4 and then subtract 4, these end up canceling out and make a 0. And so when you add 0, you just have 0. Whereas if you multiply and then you divide, they cancel out, but they cancel out to 1. So that is something that is going to come in handy, is knowing that when you add and subtract something, it becomes 0. But when you multiply and divide something, it becomes 1. Because it's just a different operation, right? Okay, so that'll help us with this lesson today. So in two-step equations, guess how many steps there are in two-step equations? And I feel like that's super obvious. So our goal is, with two-step equations, is to get x by itself. That's what it means to solve really anything. And I say x, it could also be a, it could also be b, it could be whatever the variable is, but your goal is to get the variable by itself. So this is what it looks like. Most of the ones that you'll see this year are going to just have that exact same format. So we have a couple different parts. So this here is the coefficient, and you might be familiar with some of these. So that's the coefficient. That's the number of times the variable shows up. And remember, there's always a little multiplication in between the coefficient and the variable. That's the variable. And then we have two numbers that we call the constants. Because there's no x's attached to it. Since we're solving, we're going to be using SADMEP to determine the order of getting rid of stuff around x. And you're like, what's SADMEP? That's just PEMDAS in reverse. So PEMDAS is to simplify equations, but if we're solving, we always go SADMEP, where we start with subtraction, we start getting rid of that subtraction first, and then we work our way up to parentheses. Kind of like if you put on your socks and then your shoes, to take it off, you would take your shoes and then your socks. So it just switches the order that you do stuff in. So whenever we're solving, we're going to look for stuff to add and subtract first, and then we'll deal with multiplication and division later. So we're going to draw it on a scale. You don't actually have to draw the scale every single time, but it does help to like understand what's going on. So to keep the balance of the scale, you must do the same thing to both sides simultaneously. And I really hope I spelled that right. I teach math, and not English. So let's start out with this. So remember, the equal sign is kind of like wherever this is. So this is my mathematical balance. So in this one, I have 5x minus 1, and I have 14 on the other side. So first, according to SADMEP, I want to look at anything that's being added and subtracted. Right now, the only thing that I'm adding or subtracting is this minus 1. So to get rid of it, I have to add 1. But remember, I have to do it to both sides simultaneously. And what that does is it cancels out my 1's. And since it's adding, subtracting, it comes out to 0. So now I have 5x on this side. And on the other side, 14 plus 1 is 15. It's maintaining that same equality because I did exactly the same thing on both sides. Okay, so that takes care of the sa. Now let's do the dim. I don't know how else you would say it. So the division and multiplication. And that just really refers to the coefficient in front of the x. So to get rid of that 5, remember we're multiplying it right now. So I'm going to divide both sides by 5. And what that does, it will cancel out that 5 to become a 1. So the x is still there because 1 times x is just x. So on the left side I have x, and on the right side 15 divided by 5 is 3. And I'm done because x is by itself, and so I would write x equals 3, and I would be done. Woohoo! Normally what you'll see is you'll just write this top part. You won't actually have to draw the scale. If you want to draw the scale, you're more than welcome to. No one's going to get mad at you, but you don't have to draw the scale. So what did we get rid of first? We got rid of the -1 first because it was subtracted. And remember, in SADMEP, we always do addition subtraction first, and that allowed the term with x to be by itself. Because remember, our goal is to get at the x. It's to get x by itself. So we're taking away the layers that are around the x. And so our first goal was to get whatever has x by itself. Get rid of all the extra stuff. Next, we got rid of the 5 because it was directly attached to x because of multiplication. And that accomplished getting x by itself. Because remember, our goal at the end is always to have x by itself. It can be on either side, but you do have to get x by itself. You could also use the shoes and socks method, and I went over this in another video that I will link here just with one-step equations. But sometimes it helps students to kind of list out the PEMDAS so that it's easier to see the SADMEP, I guess, when we're reversing. So remember, here's our equation over here. So on this, PEMDAS is going to do on the side with x. So here I did first multiplication by 5. So multiply by 5 because PEMDAS, right? So if we don't have parentheses, we don't have exponents, we do have multiplication. So we multiply by 5. We don't have division. We don't have addition, but we do have subtraction. So then we subtract by 1. Okay, so that takes care of the side with x. So to go the other way, we would not only switch the order, but we also have to do the inverse in order to get rid of the operation. So I would add by 1, sorry, and then I would divide by 5. And I'm going to apply this to the side with just the constant, which in this case is the 14. So I would take 14, I would add 1, which is 15. Actually, I'm going to erase that, and I'm going to put it next to my step 1. So I did 14 plus 1 is 15, and then I divide it by 5, which is 3. So my answer is x equals 3. Notice how I got exactly the same answer. You can do it either way that you prefer. Personally, I prefer this way. You might prefer it this way. Either way is fine. I think this is more writing, but whatever. It's totally up to you. So we have 2 methods, and I'm just going to write these out so that you can like pause the video in a second and then have them for the rest of your life. So at the balancing equivalence method, first you apply inverse of constant. And these are on the x side. On x side. So then I would add 1, and I would have 5x equals 15. And then I would apply inverse of coefficient. So then I would divide by 5 on both sides. And then I get my answer, which is x equals 3. And you have to write answer as x equals your number. So I'm just going to put a little box around it to see I'm done. This is all I would expect. This is normally what I would see on a student test, because no one has the time and energy to draw scales, but if you do, cool. The shoes and socks method, first you're going to, on the left side, write out PEMDAS order. So you would do like so we said like first you would multiply by 5, and I'm just going to write it like this. I don't have to write out the whole thing. And then I would subtract 1. And then on the right side, I would write out SADMEP order. So then in the SADMEP order, it would be +1 and then divide by 5. Apply to right side. So then I would take the original number, 14, and I would add 1, which is 15. And then I would do 15 divided by 5, which is 3. And then I would still write x equals 3 as my answer. So, which is the same as the other one. I'm going to copy that. Woo. iPads are so cool. Okay. So pause the video, write down those two methods, and then we're going to do some practice. Okay, so I'm going to do a mix. I'm going to do this side and the balance method, and this one I'm going to do socks and shoes. Okay, so let's get started. And again, the X doesn't matter. It can be any letter. So in this one, first I want to do, remember it's all SADMEP. So I look for whatever is being added or subtracted, which is this 9. So I'm going to subtract 9 on both sides. What that does is that gets rid of that. So I have 2a, and then 1 minus 9 is -8. Okay. And then my next step is to get rid of this 2, which is being multiplied. So I divide both sides by 2. And now I have a by itself, because 2 divided by 2 is 1. -8 divided by 2 maintains the negative. My answer is -4. And I can always check. I can plug it back in and be like, oh, 2 times 4 plus 9, or -4, sorry, plus 9, and we just want to make sure it equals to 1. So that would become -8 plus 9, which is equal to 1. And that works out. So I would recommend checking your answers. We'll do another one with the balance method. So first, again, I'm going to add 13 to both sides. And be careful with negatives. They will kind of try to mess you up. So this cancels out the 13s. And -173 plus 13 becomes -160. And if you're not sure, just picture a number line with this -173, and then we move 13 spaces this way because it's becoming more positive, which becomes -160. Okay, and then I still have to divide by -8 because the -8 is all together. You don't just divide by 8, you always divide by everything that's in front of the x. So we're going to divide by -8 here. Woohoo! So now this side becomes x. And then on the right side, I have a negative divided by a negative. So the negatives cancel out, and I just end up with 20. And that's my answer, is x equals 20. Like I said, I really like this method because it's just kind of very straightforward. The other method's good too. Let's try it. So on this one, I have shoes, which is multiply by -1, and then, or my socks and shoes, so multiply by -1, and then I'm going to add 6. So in reverse, with the 15, I'm going to subtract 6, and then divide by -1. So I would do 15 minus 6, which is 9, and then I would divide by -1, which is -9. So my answer would be x equals -9. And that checks out too. Again, I can check. So -9 plus 6. The double negative becomes a positive, and 9 plus 6 equals 15. So that works out. And then finally, let's try this one with the socks and shoes method. So I do the left side. Oh, but this one's tricky. Notice how I actually changed it. So the B is in a different spot than before. There's 2 ways to do it. You could just keep it like that and then work on it. Or if you really wanted to, you could change it back so that it's 5b minus 2 equals 3. This is keeping the equivalence. I didn't change any signs. I just moved it around so that the variable was where I liked it better. Okay, so in this case, I would multiply by 5, subtract 2. So the opposite would be to add 2, and then divide by, oh my gosh, I can't write it in. There we go, divide by 5. Okay, so then I have 3 plus 2 is 5. And then I have 5 divided by 5 is 1. So B equals 1. And always remember to use the letter that you are given. So in summary, use whichever method feels more comfortable. Like you probably saw, it takes about the same amount of work, but so just use whatever is more comfortable for you. You don't need to draw the scales, but sometimes students do. They like to draw things, and yes, it takes more time, but if you're going to be able to do it better because of it, you go for it. Adding, subtracting makes 0, multiplying, dividing makes 1, and always deal with the coefficient last because you're basically getting rid of everything that doesn't have x, and then you'll deal with whatever